Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from three-dimensional geometry. And here we are given this problem where we have to find the equation of a plane passing through a given point minus 1 comma 5 comma 6 and parallel to these two given lines, right? So here we are going to discuss the concept when we are given a point and two lines, and we have to find the equation of a plane passing through this point and parallel to these two given lines whose equations are given in a symmetric form. So now to understand this problem, let us first draw a rough diagram. Now see, we have to find the equation of a plane. Suppose this is the plane whose equation is to be obtained, right? And this plane may be denoted by P, and this plane P passes through this point, say A, whose coordinates are minus 1 comma 5 comma 6, right? And the normal to this plane P may be drawn like this, and this vector, that is vector n, is the normal vector to this plane P. So now let us assume that the direction ratios of this normal vector are A, B and C, right? And now we are given that this plane P is parallel to these two lines. So let us denote this line by L1 and this line by L2. And this plane P is parallel to L1, and P is also parallel to L2, right? So here we are just drawing a rough diagram. So here we can take the line, say L1. This is the line L1, and suppose here we have the line say L2, right? So when this plane P is parallel to these two lines, say L1 and L2, then this normal vector is perpendicular to these two lines L1 and L2. So when a given plane is parallel to a line, then the normal vector is perpendicular to the given line. So this is the concept, right? So when a plane P is parallel to say some line L, and in this case we have the plane P and the two lines L1 and L2, and P is parallel to L1, then the normal vector, that is vector n, is also perpendicular to this line L1, and here vector n is perpendicular to this line L2, right? And here we are considering the direction ratios of the normal vector as A, B, C, and the direction ratios of the line L1 are given by minus 1, 3 and 5, and the direction ratios of the line L2 are given by 1 comma 2 comma minus 4. So here it is important to note that this is not the exact diagram, but just for the sake of understanding, we have drawn the plane P and the lines L1 and L2, right? So this normal vector n is perpendicular to L1, and also this vector n is perpendicular to this line L2. So now this point P passes through this point minus 1 comma 5 comma 6, and we know that the equation of a plane which passes through some point or a given point, say x1 y1 z1, the equation of the plane P may be written as a times x minus x1, then b times y minus y1, and c times z minus z1 is equal to 0. So this is the equation of a plane P passing through a point x1, y1, z1 where A, B and C are the direction ratios of the normal vector to the plane P. So here x1, y1, z1 are given by -1, comma 5, comma 6. So we can now write the equation of the plane P as substituting the value of x1, y1, z1 as -1, 5 and 6. We have A, then we have x plus 1, then we have B, y minus 5, and C is C times z minus 6 is equal to 0, right? So the equation of the plane P is given by this equation, and now we need to find out the direction ratios of the normal vector, that is vector n. So for this we'll make use of these two conditions, right? So we'll form two equations in A, B and C by using these two conditions, that is plane P is parallel to L1, so vector n is perpendicular to L1, and the plane P is parallel to L2, and that is vector n is perpendicular to L2. So now we know that if two vectors have the direction ratios as say a1, b1, c1 and a2, b2, c2, then if the two vectors or the two lines are perpendicular, then we have this condition, that is a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So this is the condition for two vectors or two lines to be perpendicular, whose direction ratios are a1, b1, c1 and a2, b2, c2. So now applying this equation or this condition to this one, that is vector n is perpendicular to L1. So the direction ratios of vector n are a, b and c. So we can take a1, b1, c1 as -1, 3, 5, and a2, b2, c2 as a, b and c. And similarly in the second condition, the vector n is perpendicular to L2, and the direction ratios of the vector n are a, b and c. So again applying this condition to this one, so we can take a1, b1, c1 as 1, 2, -4, and a2, b2, c2 as a, b and c, right? So first we'll have this condition. So we have -1 times a plus 3 times b, and then we have 5 times c is equal to 0, and then we have here 1 times a, then we have 2 times b, and then we have -4 times c is equal to 0. So now we have two equations. The first one is minus a, then we have plus 3b, then we have 5c is equal to 0, and then we have here a plus 2b minus 4c is equal to 0. So now we have to solve these two equations in A, B and C. Now the usual practice is to solve these two equations by cross multiplication method, but here we'll make use of the method of elimination, right? So what we can do, we can eliminate any one of the variables, that is A, B and C. So here we'll select the variable a and will eliminate the variable a from these two equations, right? So if we simply add these two equations, then we can see that here we have plus a and here we have minus a. So when we add these two equations, then minus a and a get cancelled. So we can now have here 3b plus 2b is 5b, and 5c minus 4c is equal to plus c. and now from here we can write c is equal to minus 5b, right? Okay, now here let us introduce a scalar that is say b is equal to a lambda, right? So here a lambda is some real number and it is a scalar, so we can now express c, b and a in terms of lambda. So the purpose of introducing this scalar lambda is to express a, b and c in terms of lambda, where lambda is not equal to 0 and it is some real number, right? So taking b is equal to lambda, we can also take c is equal to lambda, right? So it is up to our choice. So we'll take b is equal to lambda, so that c is equal to minus 5 lambda, right? Substituting b is equal to lambda in this equation, so c is equal to minus 5 lambda. Now substituting the value of b and c in either in equation 2 or in equation 3. So we'll take equation 2. So we have minus a plus 3 lambda, then we have minus 25 lambda is equal to 0. So when we take c is equal to minus 5 lambda, then it is 5 times minus 5 lambda, that is minus 25 lambda. So we have minus a minus 22 lambda, and minus a is equal to 22 lambda. So a is equal to minus 22 lambda, right? So the introduction of this scalar lambda has led us to the values of a, b and c in terms of lambda. So a is now minus 22 lambda, b is lambda, and c is minus 5 lambda. So now let us substitute the values of a, b, c in equation 1 to get the required equation of the plane passing through the point minus 1 comma 5 comma 6 and parallel to these two lines, right? So here we have minus 22 lambda, then we have x plus 1, then we have plus lambda y minus 5, then we have minus 5 lambda z minus 6 is equal to 0, right? Now see here lambda appears in all these three terms, so we can here get rid of lambda easily by dividing both sides of the equation by lambda, and since lambda is not equal to 0, right? So we are left with minus 22 x plus 1, then we have here y minus 5, then minus 5, and z minus 6 equal to 0. So now we can easily simplify this expression. We have minus 22 x minus 22, then we have y minus 5 minus 5z plus 30 is here we have 30, and this is equal to 0. So now we have minus 22x plus y minus 5z, and minus 22 and minus 5 is minus 27, and here we have plus 30, so this is simply 3. So here we have plus 3 is equal to 0. So now multiplying both sides by minus 1, we can also write this equation as 22x, then we have minus y plus 5z minus 3 is equal to 0, right? So this is the required equation of the plane P, that is 22x minus y plus 5z minus 3 is equal to 0, and from here we can easily conclude that the coefficients of x, y and z gives us the direction ratios of the normal vector. So the direction ratios of the normal vector are given by 22 minus 1, and then we have 5, right? So viewers, this is how we can solve these type of problems.